Okay, for people joining the live stream, coming back after various vacationy and trippy types of things, we are starting up a bunch of meetings again. And this is one of our infinite series of meetings about incremental language development for Wolfram Language. So let's get started. Subset functions. Now, I mean, one question about all of these utility functions now is, now that the function repository is up and running, how does this stuff relate to what's there? And I've certainly seen some, recent function repository entries that I have to say, I was saying to myself, gosh, this would be a good built-in function. And I think we do intend to have some kind of flow from function repository to, to built-ins and so on. I mean, like for instance, if I look at just the weekly digest here, people with me?
Yes.
Like I can imagine take after, that's a not completely, that's something that I could imagine being useful. This, position max thing, I've certainly used that a zillion times.
Exactly, and that's one of the items in the agenda today.
Okay. All right, but things like, I mean, who is trying to figure out what, then clearly the work going from a function repository function to a built-in function can be quite large, but I'm just trying to understand, who, oh, that's a nice idea. This min-max rounded, that's a nice idea. Useful, yeah. I mean, yeah, this is another, I mean, there's a bunch of things here where these are clearly useful, but they're not, developed well enough to be built-in functions. Who and how are we going through to analyze that question?
I don't think we have a mechanism yet. It may be a bit early. Perhaps once we see some functions being used multiple times in other places, then we would consider them for system.
Mm-hmm.
Yeah, I have to agree with that. I mean, unless we see something that we just all say, oh, gosh, why don't we have this forever? But
well, have we seen any of those yet?
I don't think so. We've seen good functions, but I don't think any that hit quite that particular chord.
Okay. All right. Let's take a look then at the subset functions. Is Tony here to represent these functions?
Yes, I'm here.
Yes, so these are like variations of the sequence functions, but with orderless pattern matching.
So why didn't you just say sort of the sequence function? Oh, I see what you're saying. I don't understand why this isn't just cases. I'm confused.
You can think of taking all the subsets of the list in the first argument and then taking cases on the result of subsets.
But, oh, I see what you're saying. So this is a subset, but do you do it much more efficiently than that?
Yes, I'm actually using the Sparkle query evaluator to do some really efficient things in those functions because I needed them for some experimental new functions.
But when you say the Sparkle query evaluator, is this going out into some external form and then coming back in again, or is it nicely?
So there's one common code base that I'm using in 3 different places, and one of them are those subset functions.
But so this is, what is it? Is it C code or what is it?
Currently it's top level.
Okay, fine.
So the things become really tricky and complicated once there are more complicated expressions that contain a couple of named patterns in them. Then the order in which you evaluate or find those patterns does matter.
That seems like a mess.
Yeah, let's say the second last subset cases example. Yeah.
I don't even understand what the heck that is. X2. Why do you need these, Tony? Why do these come up?
So, for instance, in RDF entailment or RDF schema entailment, we are trying to find certain combinations of triples that then entail an additional triple.
I see. Okay, you've given this here. Subset cases.
So subset, a subproperty of is a transitive property. So if XY is there and YC is there, then it's also X and C. Yeah.
It's interesting. I mean, this is actually bizarrely related to these networks that are in my latest fundamental physics stuff. That is really odd. Yeah, because you have essentially a soup of triples, and you're saying there is a threading through this soup of triples.
Yeah, they can appear anywhere.
How bizarre. You know, there's never anything actually new. Okay, because this has come out of some. All right. Well. Okay, so in this case, then. Right. So what this isn't doing is removing those things from the soup, right? It's just saying you are replacing those things with this, right?
That is what subset replace would do. Yeah. It takes all the matching triples and inserts the right-hand side.
You know, maybe offline here, I can point you to the stuff that was recently done for the physics project that is an efficient implementation of a bunch of things like this. Maybe is Sushma in this meeting?
I am here, yes.
Maybe you could connect Maxime to Tony and take a look at that. Yep. Well, because this has come up in a completely and utterly different way, I am more inclined to agree with it. Right. So this, yeah, right. Neil, I mean, I have to say that yeah, all right, two subset cases. So I see. So this is threading through a graph, so to speak, seeing how you get from. Yeah, all right. I guess I kind of agree with these.
And one non-trivial feature is, if you scroll down again, if you were to reorder all of those edges in the last pattern, in a knife evaluator, you would blow up the memory. So there's some topological sorting going on there that evaluates this pattern efficiently.
Well, that is interesting. All right.
So Tony, in the case of overlaps, is this supporting all the various cases of overlaps?
So far, it supports true and false for some pattern types. So this is not a full implementation, just the cases I needed from this function so far. In some cases, different pattern types need different implementations. For instance, here you see just a case where you have a fixed length subset, yeah? But you can use repeated or repeated null. That means optional elements. Yeah.
Yeah, I get it. But let's talk about the overlaps thing for a second. So the issue is in, for example, subset replace. Okay. When you are, there might be many overlapping. I mean, there's also one can imagine a subset replace list, although I think that's not necessary right now. You get what I'm saying?
Yes. So sequence replace for now doesn't have any options relating to overlaps, so I haven't considered them in the subset case neither.
What does sequence cases have an overlap option?
Yes. So there are 3 possible values.
Yes, there we imitated string cases.
You know, the fact that we have a dash greater than versus one of these, somebody could Devin, are you the PM here? Could you point this out to Brian and just say, for goodness sake, run a cleaning pass on these?
Yep, sounds good.
Okay. Okay, so wait a minute. What does all mean? Multiple sublists that match the same pattern are all included. Multiple sublists that match the same. Tony, explain.
Yeah, and in some cases, you could think of a pattern, let's say X blank blank, comma, Y blank blank. There are different ways that pattern can match.
Yes.
And even so, it's the same sequence that it is matching. Yeah, it's binding differently.
I see. And is that what overlaps all does? Is it deals with the different binding cases?
As far as I understand, yes. So basically, it's related to replace list.
Okay, so let's take a look at this one here. All overlaps. So this is rather arbitrarily, I mean, there's different ordering, there are different things you could do here, right? For overlaps to true, that is only doing some sort of tower of overlapping, whereas this is doing the combinatorial set of cases of overlapping. Is that right? As this one de-overlaps, so to speak, what you're seeing is, right, that's certainly not all the possible overlaps.
Yeah. So in practice, I have used or needed the overlaps true more because with overlaps for all, I wouldn't be able to draw more conclusions, at least in the case of RDF reasoning. So
why is overlaps true enough? By the way, what are we doing when we put it in the full language? I mean, the RDF triple thing is specific to your Sparkle subsystem, right? I guess you can be modeling this perfectly well with lists and things. Never mind. Go ahead. What were you going to say? Why is it sufficient to do this overlaps true thing?
Well, it's a little bit difficult to explain, so I would have to go into the details of the implementation.
I mean, to me, it seems like your overlaps case. Whew. Wait a minute. Are you saying that this is overlaps true by default?
Yes. I followed the precedence of the sequence functions.
And they have overlap true by default.
These follow the precedent of the string functions.
Wait a minute. Sequence cases has overlaps false by default.
Yes, these, I think the sequence cases and sequence position, no, string cases and string position, for some reason, have a different default. And this has been propagated to sequence cases and sequence position.
Wait a minute. String cases, you're saying, has default is overlaps to false. Okay, so you're saying string position has a different default. Is that what you're telling me?
Yes, if I remember correctly, that's the case.
Interesting.
I think this tried to use the setting which is most used for each of the functions. But yes. I never understood exactly why.
I think this was carefully thought about. I don't think this was completely silly. Okay, so you're proposing to base your overlaps defaults on these. Is that correct, Tony?
Yes. I forgot the details because it was some time ago that I implemented it, but I agreed with those and I found them useful like that.
All right. Okay. Okay. So subset count is kind of weird and probably not that important, but we might as well have it.
Yes, cases, position, and count always formed a triple.
Okay. All right. Fine.
Sequence, count. Yeah.
Let's do it. Okay. So Tony, I agree. Let's put these in.
Okay.
So these are 4 functions, right, Tony?
5.
Well, with the count.
4. It's 4.
4.
4. Yeah, that's right.
Okay.
Okay. This is cool. I mean, there may be some other issues, but why don't you get the thing, put in, documented, etc.
Okay.
Okay. Next up, very different topic. Dollar history memory constraint.
Yes, this is something you suggested, and yeah, I think this is useful.
Yeah, I think
there are
so
several
too.
things to decide here.
Right. So dollar history length just starts erasing from, it erases both inlines and outlines, or only outlines?
I don't know. Good question. I don't know.
Okay. All right. So honestly, history memory constraint seems a lot more useful than history length. I mean, I would never set history length, but history memory constraint I could imagine setting.
History length is something that we use a lot to set to 0 because, yeah, we want to save as much memory as possible, or we are doing testing for memory leaks and things like that. But rarely we set it to 10 or something.
Okay, so here's a question. If, in the modern world where every cell has a UUID and all these kinds of things, could we imagine a situation in which we got background noise, by the way, please, somebody put yourself on mute, please. Anyway, where you are sort of pushing it out to mass storage if it's older. You get what I'm saying? So I could imagine a situation in which you would want to say those outlines that are far in the past, just save them in files, right? Rather than keeping them in memory. Maybe that's silly. I don't know. Comments.
That seems like a second iteration of this idea.
Well, I know it's a second iteration of the idea, but we might as well get both iterations. Let's see.
The main thing I was thinking about is whether we want to limit the total amount of memory or the memory of each of the in-outs. Like saying, don't store the large ones.
Yeah, well, both of those are interesting. I agree that one. Let's see. Actually, we have a comment on the live stream from Carl, who's commenting about the subset functions interacting with data set. Did we think about that? Did we lose Tony here?
Sorry, I was listening.
Carl on our live stream asks the question, how do the subset functions interact with data set?
I don't think there's anything specific to those functions.
No, but I understand. But I mean, a data set in principle, I don't know what sequence cases does for data set. Sequence cases could work on data set. I bet it doesn't right now. But data set can contain a a data set internally can be a list of associations and things like this. And the question is, can one use this? And by the way, have you thought about how this thing interacts with associations? Because I can imagine I assume it just works, where this RDF triple has, for example, a source and a sink in an association, let's say, and those could be in any order. Am I making sense?
So I think those functions should work on the same heads, probably all or just list, like sequence functions. And the other comment is that in dataset, you can apply a function at any level you wish, including those subset functions, which means they should naturally have an operator form, maybe together with the sequence functions, if that's possible.
Why don't you look at that? It's a good question. I'm not sure. But you understand what I said about matching associations? I think that will just work. Does it work?
Sorry.
What would be an example?
Well, I mean, an example is it match Q? Well, do these the equivalence between? Okay, so let's do this. A goes to 1, B goes to 2, versus actually, why don't we do? What happens if I say random sample? Does this work? Probably not, because it's expecting a list. Oh, it might work. Does this work? Yeah, okay, it does. So if I say,
I think you mean random choice.
No, I mean random sample, and then I mean table of that 10 times. That's just going to give me those in random orders. Okay. Okay, so now I want to say, if I do sequence cases of, am I confused here? What I'm trying to do is a sequence. I'm trying to see whether the sequence cases thinks that A arrow blank, comma B arrow blank. Look.
So we have a precedent from cases. So cases on an association works as if it was its values only. I think that's the starting point.
Okay, but what does this do? Does this generate? Does this eek?
Probably that would require the use of key value pattern or something like that.
Okay.
So at least sequence position or subset position could return the keys of the association as opposed to the indices, the number indices.
Yes, I understand. All right. Well, look, let's not. Okay. So as you work on these, can you think about the association case?
Yes.
Carl mentions, be nice to be able to transform a data set into a bunch of RDF triples. Can you?
That's possible, but it depends highly on how you want to model your data in RDF, which means you have to choose a vocabulary and then you can transform it.
What does that mean? So you've got a data set and it's got rows and row labels, column labels.
Yes. Then you would have to choose, say, what are the IRIs for those rows and columns? And well, then you basically have your triples.
Do we have a function that does that?
Not yet, because that's not really automatic. So there are certain special cases. If you have a relational database like thing, there's a default mapping to RDF, and you can customize that. But for a general Wolfram language expression, it's more difficult.
Fine. All right, let's go back to history memory constraint. Okay, so I mean, what you're proposing is a sort of a simpler concept, which is some kind of dollar, max history memory or something like that. I mean, you're saying, what is the maximum size of thing that you should store in an output line? And if it's too big, I mean, that's analogous to what happens if I do, if I say audio capture, and I just go, yakety, 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 yak, hello, hello, hello. We're going on and on and on and on and on. And then I press stop. There is a good chance that that will be too big. It's still stored in the WAV file. But that could be too big to store in the file, right? To store. Oh, no, that isn't. No, I'm confused. That's not in memory anyway, right? That's in a file.
Right. But say a really big array or something like that.
Array of what?
Of numbers or whatever.
Well, you mean that will hit the too big thing. And that isn't yet. Is that yet unified with this, it's too big to store? Look, dataset has this feature as well. I mean, if I say dataset of range of like 100,000, let's see what that does. Okay.
But I don't think this has been implemented yet in dataset. So Chris has been working on it.
Okay, what is it?
Sparse array. So try sparse array of that range.
Okay, there we go.
Right.
Okay. Well, so there are two different issues. Do you store it? This is a question of the kernel storage. This is like the too big situation, right? Where you're not storing in the notebook. And this is exactly what too big should do, right? It will say something like, you say range of 10,000 or something, and you'll, great, range of 100,000, and you'll get this, right? And this should say data not in notebook, store now, right? Because it isn't in the notebook, is it?
No, I don't think so. It is.
You're saying it is in the notebook?
It is not.
Right.
At the moment, if we save this, we cannot recover it later.
Right. So this should work. And Sushma, it sounds to me like this is related to some of the projects that you were managing. I don't know whether Devin has taken those over. But this should, in this case here, it should have a thing just like this. Does that make sense?
Yeah.
Yeah, and I think we're having a meeting later today about this exact issue.
Not with you, but
yeah, like just in general.
Okay, fine, because that's the consistent. Okay, so what we've got, let's see. We've got two different issues here. We've got, does it store in the notebook, and then does it store in the kernel? Because those are two different issues. I mean, you could store in the notebook and not store in the kernel, or store in both, or store in neither. Make sense?
Right, they are independent. Yeah.
Right, so an output line. Okay. Boy, that's kind of weird that you could have a situation in which you say out 75 and it'll be not stored in the kernel, but it is stored in the notebook. In other words, let's say your kernel died. You could actually recover out 75 from the notebook. True or not true?
Yes, but we can have that situation now with history length 0 and then things that are printed in the screen.
I understand, but we're not trying to do that recovery now at all. Right? I mean, in fact, more than that, as soon as the kernel dies, we get rid of all the numbers, which I guess we have to do. No, I mean, but in the modern UUID, in the modern case, okay, in the modern case where every outline has a UUID, that's part of percent modernization, okay? It is the case that we could, in fact, go back and go back and recover something that was there in a previous session, previous kernel session, right?
I guess so.
Definitely. So we actually have several independent things going on here. We have, right, so we've got a kernel history thing, and we're going to say if it's bigger than such and such a size, don't store it in kernel history. Now, if it was semicoloned in the notebook, you're out of luck. It's not going to be in the notebook either, right? But if it was too big, it might be in the notebook. Okay, so I think this is for Devin to comment, to take to Parth about notebook, cell UUIDs. Do you understand what we're talking about here?
Yeah.
Okay. All right. The
I think the main thing here is a way to control memory in use, because memory in
Sure.
use typically grows a lot by the history.
Right, but I mean, the simplest thing is don't store it if it's bigger than 5 megabytes or something.
Right. And that's easy to understand, because if we have a global limit, it's kind of difficult to predict which ones are being stored and removed.
Well, except that one way to look at it is, I just want a reasonable history, but if it's going to go crazy, just start dropping it. But I agree. I mean, what will we set the default? What will we advise people to set the default to for a single thing? 10 megabytes or something? What? I mean, because
probably by default, I would say it should be infinity.
Yeah, but default it should be infinity. But I mean, see, if they don't do that, then things like graphics, a typical graphic can be a few megabytes.
Right.
Look, I think there are two cases here. I mean, there's a maximum size for an individual element. This is some kind of dollar max out memory, except that's obscure. Max.
And as you said, this should control also the in, because perhaps we have very large inputs.
Yeah, okay.
So perhaps it's max history cell memory, or
it's not cells.
Well, what's the in-out pair?
Do they have to go together? I don't think they have to go together.
Right.
I mean, we could imagine this. Element memory, item memory. Okay, so what does it do? So you set that to a megabyte, and something is beyond that. What do you get back? I think what you get back is an unevaluated outline. Do you agree? I think you get a message in an unevaluated outline.
I don't understand. What's that?
Well,
what's
I mean,
unevaluated?
So you say out 85.
Oh,
I say that, I get that.
Mm-hmm.
No value.
Yeah, that's
what I think
history length works. Sorry.
Okay. Does history length generate a message if you are accessing an outline that was there but has been removed?
No, I don't think so. I think it just returns out 89.
I claim it should generate a message. And I think this should too. I think it should generate a message saying this outline was dropped because it exceeded the history element memory limit.
So the message is when you try to access it later. No, not
that
when
is correct.
I see.
Yeah, that's correct. If you try to access it later, it says, sorry, it's not there because blah, blah, blah. So I think this is pretty reasonable. Any objections to this?
I'm still a bit confused about the in-out, because sometimes the out is very large because the in was very large.
Fine. Kill them both. I mean, this is a separate item. They're separately controlled. So if the in was huge and the answer was 17, then there's no reason to get rid of that outline. See what I'm saying?
Right.
Now, actually, it's an interesting question. I think there's no choice if you have, okay, there is a bizarre case, but I think it's a bad case, which is you've got an iconized inline that's huge. But iconized doesn't offer you any don't store it in the notebook option. Get what I'm saying?
Yep.
Arguably, iconized should be able to pull things in from a file. See what I'm saying?
From a file.
I think that would be a nice feature. I mean, I don't think it's the most urgent thing, but right. So in other words, you could iconize a bunch of images, for instance, and they could be actually pulled in from files. So that's related to the thing about having notebooks with indirect referencing of assets, you know, just like an HTML page has indirect referencing of, for example, image assets. Do you get what I'm saying?
I think I understand, but that looks more difficult to implement. And probably we would need other people to discuss that.
No, I understand. I understand. Okay, let's go back here. Okay, so I think we've agreed max history element. Max history memory, is that the right name? Is that the right name?
Perhaps in-out instead of element.
No, because it's in or out. That's really confusing. Well, we do have $line, don't we?
Yes.
So we could do something with that. Kind of obscure. Max line memory. It sounds like we're talking about the old days of telephone lines or something. Comments on that max line memory? I mean, it does go along with $line. Now that is a little bit unclear on whether it means in or out.
Perhaps in the front end there is a terminology, some terminology for the two components of a cell, the in and out.
No, I think it's just in and out. I mean, I think input cell, output cell. Okay, look, I don't know whether this should be called history item memory, history element memory, or max line memory, and so on. But Devin, can you please make sure there are notes on this, and then who would get to implement this?
Lou, perhaps? I'm not sure.
Is it in the front end space? I guess it is. I'm not sure. I'm not sure if this is more. I don't know. That has to be reviewed. Okay.
I was thinking that perhaps it would be nice to have some sort of mark in the in-out, that some grain or something that denotes it has been removed. Because how do you know which ones have been removed?
Well, how do you know with $history length?
Well, you don't, but somehow history length is simpler because it's not a matter of holes.
Well, but it should work the same way.
Yes,
and the answer is very simple. We already know the answer. The answer is the same as the answer if I kill the session, which is that you get those deflated in-out labels. You see what I'm saying?
I see. Without a number.
Well, those ones don't have a number, but they also deflate, as in they go italic and they go gray.
I see. Yeah.
So I would say we would leave the number here because it's still the same session, but it would, visually deflate, so to speak. And you could imagine a situation in which the inline for something is left and the outline is not. Look, I think that's what we do. We deflate the thing. We have a mouse over for the in outline that says it's been removed because it's too big. Make sense?
Yeah, I think, yeah. I like that.
And then this is one of these. I can't believe we got away for 30 years without having this. I mean, I guess that's because people just set $max, dollar history length. What are we going to call this? What are we going to call this? History line, max memory. That's a bit confusing with respect to the in-out thing.
Somehow the history doesn't play much of a role here because it's in the other case, it's history because it's from this moment to the past. So, well, here it's more like an independent thing of the other cells.
So what are you suggesting here?
I'm wondering whether the word history should be there.
Well, what else could we give it? Line? Store? I mean,
I'm still thinking that in-out should be there somehow.
It's a little weird. Because it's in or out.
Right.
Well, we can certainly consider that as let's get it implemented, and as it's implemented, we'll think about this. But then, okay, so here, this would be, now let's talk about the total case. The case where you just say, I want to use 200 megabytes, but I don't want to use more than that.
Right, so those are 200 megabytes total for the all of the ins and all of the outs.
Right. And so then you have to kind of heuristically guess what to drop.
Yes.
So it's a trade-off between recency and size. What is the obvious way to do that?
I guess we store if we obey all of the constraints.
I understand, but I mean, as you add something in, the issue is that particular line is only a megabyte, but it puts you over the edge. Do you drop the new line? No, you do the least recently used. Right, you drop the least recently used, but you could easily end up in a situation where you fragment and where you could be dropping. If you had known the future, you would have dropped less. See what I'm saying? Because you could end up dropping a big, 5 separate lines, each of which is quite small, when actually you could have dropped only 2 of those lines based on what comes in the future.
Yes, this is what, there is a comment there from Brian, and he was basically suggesting the same thing.
What is he suggesting?
I mean, one simple idea is look for the bigger one, and then drop from that one to the past. But that could be too many. Perhaps all of the other ones to the past of that one are very small.
Yeah, I don't think it's a good idea to just say, go every time there's a big lump, drop everything before it. That seems wrong, if that's what you're suggesting. I think what one wants to do is, look, there are two parameters. How recently was it used and how big is it, right? So the question is, what is the optimal thing to do given those two parameters? What is the optimal way to achieve a certain level? I mean, why am I reminded of these, efficient frontier portfolio analysis type things? Somehow it's the same type of problem. I think there's sort of a standard what am I saying? A standard all right, look, can we please think about that question? Is there a standard and obvious way to do this? Nothing that I immediately know, but you just got to think about it. It's you're filling in. You've got these two parameters, right? You've got a plot. It's got how recent was it? How big is it? Right? And your goal is to color that plot, right, in such a way that you have the best, in some sense, the best coverage. Am I making sense?
Yes, I think the goal should be to maximize the number of in-outs that we keep.
Fine. Or the maximum number of independent ins and outs that we keep. Okay, well, if that's the goal, right. I mean, whenever there's a really big one, you probably want to throw it out. But again, I'm pretty sure that somebody who knows about optimization and so on knows the answer to how best to do this. So can we please ask the optimization crowd, Rob and people like that?
Okay, yeah.
Okay, we have a couple of suggestions from Brian on the live stream. History memory size, history item memory size. Not crazy.
Do we only care about history? What about like large cell prints or copying and pasting into a notebook?
Well, those aren't stored in the kernel anyway.
I see.
Those are just pure notebook things. All right, look, we've got a path forward. The in-out memory, I think this history memory size is not a terrible one. Memory. Okay, am I storing this file somewhere? Or do I not need to? Has everybody got have you got the notes of this?
Yeah, I have it all written down.
Okay, all right, I'm not going to store it then. Okay, let's go on to the next item. Actually, we had some other comments on the live stream. Complaining about the find dialog in notebooks. Yeah, that thing is absolutely horrible. That's just terrible. I mean, that's a question for Parth, what the story of that is. I have heard comments about how it's getting improved, but and there's also the question of, does it even bother to look at these absolutely giant cells? Right? Everybody's silent here. Maybe we should get Parth if we're going to discuss this any further. Okay, Devin, for you to, let's not do that today, right now, but let's ask him what's happening with the find dialog, expect to discuss that in the user assistance meeting.
Sure.
Okay.
Yeah, I don't think we are the right group here.
Okay. Some comments from Carl about dataset to RDF. Interesting to have automatic vocabularies for quantities entities. Yeah, well, those are great function repository functions, and Carl, you are highly encouraged to contribute to the function repository. Okay, Ethan is asking about ordered associations, and also unordered let's see, what are we having right now? We have that whole business about ordered associations and unordered associations. That was the original plan, was to have multiple ones of these things, but it got so hairy. I mean, it certainly would not get its own, special angle bracket syntax and so on. I agree that that's a thing to discuss. We should put that on the. It's probably related to Tom's new raw data structures project, and perhaps Devin, perhaps you could make sure that that gets added to that discussion, and also make sure that we get a meeting about that project, please, as soon as Tom is back.
Yep.
Okay. All right. Let us move on here, if we can, for a little bit. Okay. Table while.
Yes. Here, I think the main question is whether to follow while, in which we have a test expression, or to follow length while, nest while, etc., in which there is a criterion function.
Sorry, what's the difference?
Yes, so in the first group, we have a criterion function which is testing each element that it finds. While in while, there is a condition which is sharing the variables with the body, and then it's general. For example, there Danny implemented a simple case in which the condition is a condition on the iterator, for example.
Yes.
But it's not a function that is applied to the result of table.
I understand. I mean, this would be nice. Is this multidimensional or is this only one-dimensional?
I think that's only one-dimensional. It has one iterator.
But in general, the interesting case here would surely be a case where table, where you have a ragged boundary to this multidimensional array. Get what I'm saying?
Yes. So if the condition is going to be only on the iterator, then somehow we can do it in advance.
Yeah.
Like that other example there. We can select from the range the cases of the iterator that we want and then just pass those.
Well, I understand. In the multidimensional case, it's a little hairier than that.
Yes, but it still could be done. The problematic case is when we want to have a condition in which we involve both the iterator and the number that was generated, the element of the array.
Yeah.
We want to do, we don't want to do the select anyway. One of the main ideas here is to reduce memory footprint. At least
sure.
In my view.
But I mean, okay, where did this table while thing come from anyway?
I think it was a suggestion from you, perhaps. Yeah, I think so. So, and you wanted to have some sort of general way of controlling iterators, perhaps to be an option. I think you also suggested an option, perhaps.
Well, the issue is, keep mapping. So, for example, one could have with scan, one can certainly have a scan with a return in it, right?
What do you mean? Do you mean a map?
No, I mean a scan.
Yes, you can do that.
Hash is greater than 4, return, 100.
I see what you mean now with return. Yes, yes.
Now, what is the case for table? It's kind of like keep generating this table until the numbers get bigger than 1 million and then stop. The most common case is going to be that the condition is on the generated thing. Because if the condition was on the indices, you could, just do that in advance.
Exactly. Yeah, so I think this is more like length while, nest while, with a criterion function rather than a test.
Yes, I agree. Now, it's also the case that multidimensional table while, I mean, yeah, so what would map while do? It's mapping f's around things until suddenly it chokes and it stops doing it, which is kind of weird. Get what I'm saying? Right, so I mean, you say f of 1, f of 2, f of 3, f of 4, and then 6, 7, 8.
Right. I mean, the question is whether we return also the remaining elements or not. Perhaps we just return the ones mapped.
I see.
And table with the, yes, in the multidimensional table, the interesting thing is how do we return only one level? We could stop at one level, but continue at the previous one.
What do you mean? You mean, I'm confused by what that would do. Go ahead.
Yeah, yes. I mean, I was trying to understand your rugged case in which we have, for example, a collection of lists, and then each one will decide when to stop. For example, stop each row when the element gets bigger than something, and not just stop the whole matrix.
Carl is quoting something on Mathematica Stack Exchange about how complaining that we have nest while and nest while list, but we don't have fold while list. Let's talk about that case for a minute. Yeah, that case seems rather straightforward. Because that case is essentially a criterion. You are feeding values in from the folding source, so to speak, right?
Yep.
And this is a termination condition for that.
Yes. And again, we need to decide what to do with the remaining values.
Nothing. You're done. I mean, just like nest while gives, in the case of nest while, once you failed the criterion, you're out of there. So similarly with fold, it has a supply. See what I'm saying?
Yes, but with nest, we don't have a list of length 1,000,000 to start with.
No, I understand, but you can think of fold as having a supply list, and you can decide sort of discretionarily how much of that list to use. See what I'm saying?
Yeah.
And so then fold while would just say, well, it fails the test. Okay, stop using the supply list.
Right.
And that does seem rather straightforward, that case. And I agree. I think we should definitely do that. Fold while list. I mean, obviously, one day we'll get into fold pair while list, but that's even more ornate. We're not going to worry about that right now.
Right. Something I'm noticing that we use test for the Boolean expression and sometimes for the function. Perhaps we should make this homogeneous and call it crit.
I think we probably should, yes. I agree with that, because this is confusing here. I was immediately confused here. That's a Brian issue. If we can inventory where that happens. I agree with the conclusion, though. But back to, so fold while list are fairly straightforward. They would work just like this, basically. Okay, so then we've got and we've got take while right now, right?
Yes.
So the question is there a table while? That's really what remains on the table here, so to speak. Okay, so take while also has the story that at some point it chokes, so to speak. Oops. Right, so at some moment it just stops taking. So the obvious analog of that in table would be it keeps going and its supply is what's specified in the index range, but at some point it just says, "Oh, I'm done," and stops. So in the univariate case, it seems to me that that's fairly clear. It will be a table with a crit.
Yeah.
The problem is table is var args.
Well, take also is var arg.
I see.
So this is a one-dimensional version of take.
Right. Well, I mean, look, in the case of the table, it has this weird question of what does its frontier look like? Right? In the one-dimensional case, it's rather straightforward. In the multidimensional case, both here and for table, it's kind of obscure. Okay, what does the frontier look like? That's what we were discussing before, right? How much I, how much J got done?
So in this case, we wanted to have take.
Let me just break in. I think it would be kind of weird if the iterators did not behave like standard iterators for do and table and etc.
But what's your point? Your point is that there's an implicit ordering, or what?
Yes. So you don't
ordering
do
is
like
flatten.
Yeah. Right. Exactly. And I think it's outermost first varies, most rapidly, if I'm remembering correctly. But yeah.
Well, it's the flatten ordering, basically. It is the ordering which, were you to unravel the thing into a flat version, that would define an ordering, correct?
Yes.
But perhaps table while should be also one-dimensional. I'm not even sure where to put the criterion argument if we make it var arg.
Well, obviously that's a problem. I mean, syntactically that's a problem. Functionally, it's unclear.
We could make it the first argument. The criterion.
That's not what we've done elsewhere.
Certainly not with take while.
Right, background noise, by the way. I have this feeling that we should get a table while, one-dimensional table while, at least in the function repository, and see what it's like. Meanwhile, I think fold while list are things we should be doing. Our Hermans on the live stream.
I like the suggestion for a meanwhile.
What?
Just kidding.
Yeah, it goes through a list of things, and as soon as there's an outlier, it gives up.
Yeah, exactly.
Okay. Table while working with parallelize. Ooh, interesting.
No. I don't think so.
Well, I mean, it's basically the analog of parallel try, isn't it?
With parallelize, you have all sorts of ordering issues. You know the order of the result, but you don't know the order in which things get done.
No, I understand that, but table while, think about it. Table while, if it has a crit, right, and the crit is local, right, because the crit, in the case of nest while, the crit has this rather complicated thing that allows look back, okay? See what I'm saying? So this is M, the most recent M results as arguments, see?
Yeah, recent means proximal, though, and this does not play nice with parallelization.
Well, I understand that, but if M is 1, then this is perfectly parallelizable, albeit a bit of a waste of time, because you might be probing, you might be trying a value out, far out in index space.
I think that I like to view these as short circuit operators, kind of like the Booleans and an or, etc. So there's a quick short circuit that says when you're done, and that you don't evaluate things after that short circuit. That's sort of an important notion in computer science, and I think that these should follow that.
Well, it's only an issue if
protocol.
there's a side effect. There's no side effect, who cares?
True enough, other than it's a waste of time, but I still think
but if you've got a lot of parallel processors, time can be wasted.
Well, I guess the question I will raise is, do we want to regard these as short circuiting or not? If not, then parallelizing is fine.
It's a good question. I mean, it should certainly be addressed. It's not obvious to me that we need to. I think that there's enough squiggle room in parallelizing, like parallel table, for instance, doesn't right now preserve, if I say parallel table, and in that parallel table, I've got, print. Look, I mean, if I do that right now,
I
do it right now, it's going to go the wrong thing, almost certainly. If I say print I mean, unless it refuses to parallelize, I don't know, I up to 10, and we'll see that is super ugly, by the way, and that really needs to get fixed. Well, I'm actually completely impressed. Look at that. How did it do that? How the heck did it do that? Returned kernel 12 first? How did it do that?
I'm not seeing what you're seeing.
What do you mean?
I have my full screen. I have a full screen set.
Can everybody see this?
I can now see 1, 2, 3.
I'm sorry. Can everybody else see?
Yeah.
Okay, so I don't understand how that worked. Unless it somehow didn't. That is just totally weird. Look, do you see this? Do people see this?
I don't get them in order. I get 1, 3, 5, 6, 2, 4.
Really?
Yep.
Oh, you know what it is? Let me go up to 20. I think it's going to fail then.
Yep.
Yes. Yes. The reason is because I have 12 cores on this computer. So the count of I don't even understand why that worked, but the count of the number of cores is larger than the number of cases that I was evaluating.
Right. I have 4.
Well, so, to be honest, this has already crossed the bridge, right? The parallel table here has already determined that there is no meaning to the evaluation order. If there's a side effect in one of these, well, of course, this is a separate parallel table, and one can imagine a parallel table while, in which case the rules for what gets evaluated when and how the side effects work.
Right. So, I would not have an expectation of a table function short-circuiting or, forcing an ordering of the evaluations, whereas a table while I might have such an expectation.
Maybe. I mean, this is the question of if. Okay, I think that's a separate question, but I think the issue of whether, I mean, I'm beginning to think that table while is primarily a one-dimensional concept. I do think that this is a perfectly reasonable thing. Like, give me all the Fibonacci numbers less than 1 million. Right? That would be an easy, in this table while setup, right? With the criterion with hello, sorry, Fibonacci of n, well then, but then what I'm doing is I'm saying, I mean, how do I say, what is the best way to say? What I do here is to say hash less than 1 million, for example, right? But I'm having to commit myself to the size of the iterator, which in a sense shouldn't be necessary, right? What will be the construct that I would get if it is a pure, right? I could imagine in this case, since it's in fact that this would be the more natural thing to do,
Well, we could have n comma infinity, because you may be also interested in getting 100.
At most 100, you're saying.
Right, exactly.
Well, I agree, but this case that I just wrote down here, which is a different sort of degeneration from the case of table, where the table, in the non-list case of table, is just giving that number of identical elements. But this case seems somewhat interesting to me. Right, just keep going as a function of n until you, I mean, in a sense, that's more what I wanted before.
I think here we may hit the discussions we had with table itself about having braces or not. Do you remember, Danny, that there were problems about?
Yeah, I remember rather too well.
Well, in the end, we don't have braces for the case where it's just table, and thank goodness we don't. That was a horrible, syntactic, awkwardness.
What?
But for the numeric case.
Yeah, this case here.
Yes, and so I'm saying that for the symbolic case, n, there are these issues of whether n will evaluate to an actual iterator.
Yeah.
You mean the evaluation semantics? Well, I mean, if it's table while, the evaluation semantics could be different from table.
Yes, that could be.
Look, honestly, this seems pretty useful to me. Really quite useful.
Mm-hmm. Yeah, I would also support n comma infinity.
Oh, sure. Yes, that's fine too.
Could you scoot it over to the left? I'm on full screen and I cannot see it.
I don't know what you're doing. I don't know what you're doing.
I see it now. I'm working on a Linux box is what I'm doing.
Well,
I'm suffering like our users. At least the Linux ones.
That's not a problem that Zoom doesn't show you the right-hand side of the screen on Linux.
True, but I mean,
take their IPO winnings and
suffering the Linuxisms. It's the Linuxisms.
Okay. I really like this. Really like that. I think we should have this.
Yeah, I think it's good to have this one-dimensional, and it fits take while as well.
Now, am I correct that the criterion can just reference the iterator explicitly?
No.
It should be able to.
No, the criterion is just on the values.
It should.
No. But what Danny is saying is that the what can happen is that it does a binding of the iterate. What is that background noise? Come on.
That's my office mate. I have to be able to speak though for this particular conversation. I've been good about using mute.
Okay. All right. Okay. So anyway, this is so what we're saying is this case here, that the n is bound before the thing is evaluated.
I see.
I'm still a bit concerned that I mean, are you trying to exclude the n comma 100 notation, or?
No, I'm not. No, I'm not.
Okay, fine.
No, I'm not. I'm just saying that you can degenerate instead of degenerating into a constant. Just repeat the first element, which is kind of useless in this case. I'm saying the sort of singleton second argument means that's the iteration variable.
It starts at 1, increments by 1, and goes until told not to.
Yes.
Yeah, that sounds fine.
And if you really want, for example, you could do this if you wanted to. You could say n, 0, infinity. If you really want it to be 0 origin.
Sure. Well, you can also give a skip.
Whatever you want to do. Yeah, right.
Yeah, it's all fine. Okay, as long as you can reference it.
Right. But anyway, so I think I like this design here. So let's try to do this. Okay.
Yep.
Okay.
I think we're running out of time here. Let's just look ahead at some of these. Oh my gosh, that business.
This is the question of whether there is an applied version of the head map, which would be useful for multi-argument functions.
So head map we had agreed on, yes?
Yes.
Even with its name?
Mostly.
Okay.
We didn't have violent disagreement.
We went through many, many other possible names and then came back to head map.
Yes, I think head map was the least bad name or something that we decided on.
Okay.
So the question was, what happens if we have functions of multiple arguments, which are not natural with map, but they are with apply?
Well, you're suggesting that head map be varargs.
It's a bit weird. It's a possibility because
it's like construct then.
Exactly. But none of our map functions is vararg in that sense.
No, I understand. I mean, head apply seems to me to make more sense, and that you can just achieve that same result by just putting them in a list.
Right.
It seems much more controlled. The varargs head map just seems, increasing the head explosion, the force of that, so to speak. I think it's hard to understand. I agree that head apply does seem like it's useful, unless I see. No, you can't really do that. I mean, otherwise, what you would be doing is each one of those would be it would be a mapping apply onto the f sub I. You see what I'm saying? And here you would say, head map. I mean, this is just getting into the utter obscurity. Apply mapped onto F1, F2, F3. If I'm not mistaken, XY there would be correct, right? Because apply F onto list XY does that.
Right, I think so.
Somebody should have, in terms of these sort of educational weird things, I mean, somebody should just there's all this functional programming, the ways that these functional programming things combine. It's I don't know, maybe that's what they teach in functional programming classes. I have no idea. I doubt it. They probably teach something much more elementary. Anyway, never mind. A comment, by the way, from Ethan on the live stream. Make sure that nest, fold, map, while interact well with dynamics. Why is there an issue with dynamics? I'm not sure why there's an issue.
Me neither.
Okay, well, look, I think head apply is okay.
And this is the discussion we were having at the beginning. This is a function that is a resource function already, but it's requested frequently. So it may be worth having in the system.
I think it's worth having.
Now, Etienne raised the possibility of having it being multidimensional, and that gets more powerful, but a little more complicated. Because position is very general, it's fully symbolic, while max requires numeric expressions.
Well, I mean, you're saying position largest by, effectively.
It's very similar to take largest already, but